Hello folks, it's BatTube here, and today we are going to be talking about how to communicate with your Valence battery and how to use the Valence Diagnostic Software. So if you don't have the Valence Diagnostic Software, you can go ahead and get it at the link in the description. It's going to be the Google Drive link. When you go over the link, click on this folder right here, the Valence Diagnostic Software folder. Double click it. And if you double click this, you can choose which one you want. I would just go for the setup, but you actually have to download the whole zip. But once you download the whole zip, extract it and only run this first one here. They all pretty much do the same thing, but just run the first one because it's just, in my opinion, the most reliable. Although they're pretty much all the same, like I said. So once you have it installed, you ran the setup and it did whatever. You open up software, just like so. So before we can even do anything, we have to communicate with the battery. So let's go over to the battery bank and show you how I am set it. How I have the RS485 to USB adapter setup based on the wiring diagram that I showed you guys in the last video. It will also be in the description below. Okay folks, so here we are. The first step before we even do anything on the software, we have to connect our battery to the PC. So what I have here is I have a USB hub that is connected to a USB extender all the way to my PC. I have a RS485 to USB adapter here that doesn't offer a 5V output, so I'm getting the 5V positive output from the secondary USB cable. I posted the diagram for this cable as well as this cable with the amp super seal connectors, as well as the previous model which uses the M12 connector. I posted the wiring diagram for both those in the last video if you guys watched it, but if not, I'll post it on screen right now, and I will also put a link to it in the description below so you guys can download that for future reference for wiring this up if you don't already have one of these systems wired up. There's a couple diagrams I've seen online, one at 300 miles per gallon or 300 miles per gallon.org or something like that. It's basically this truck that this guy has running with Valence batteries. He shows a method of using a similar adapter and getting the same results. But whatever method you did, this is how it works. And we have our battery plugged in. So if you're connecting a series group of batteries, you will be connecting the battery, the last one in series, the one that has the resistor on it. That's if you're using the RT series. Is it the RT series? The RT series, I believe. The RT or the XP series, whichever one that you can ponytail them together. You would be using the last battery in series, but this one we are connecting them individually because these aren't meant to be ponytailed together, but I am going to be in the future making a ponytail system to ponytail all these together, which is actually the reason I'm connecting each of these batteries to the software to change their ID, just so they're sequenced, so we don't have any similar IDs when we connect them all in ponytail, because we will only see data from one of the batteries because they all have the same ID. So we have to go through them and change each of their ID in sequence, 1 through however many we have. So the next one I have to do is this one. So this is the one that we are going to be using just for video purposes. Down here I have 1, 2, and 3 already labeled, so this one is going to be changed to ID 4. Okay, so let's go back to the PC and I'll show you how to use the software. Okay folks, so here we are on my desktop, and once you have your battery connected to your RS485 adapter and it's all connected to the PC, and you are ready to go. You want to download the Valence software if you don't already have it. I will leave a link in the description below with the software. So go ahead and download that and install it if you don't have it. So you're gonna go ahead. Okay, wait. You're gonna go ahead and just open the software if you haven't ever opened software. And once you open it, just close it. And now when you go into travel to My Documents, and once you go into My Documents, look for the Valence Technology Incorporated or just Inc. folder, and then inside that folder you will see a Valence U-Charge XP Module Diagnostics Software folder, and that's the folder that I'm in right here. And this has your data logging. Well, ignore that. You can set it to save your data logging like I had before. So this is the only files that you will see in there. So you want to open up this one, the config file. So I'm gonna right click, edit, and I'm gonna scroll down to product configuration option, and I'm gonna change that to false. So basically that is false. So the configuration, the production configuration option is basically the configuration option for the standard consumer, just someone who's using the battery, not like a Valence tech. So if you change it to false and save it, it's basically gonna give you just a slightly different software with a couple more options. I think it's more for maybe a Valence technician. So once you've done that, you can go ahead and open the software. And the only reason I do that is just because you may as well have all the options available to you. So this is just giving you a bit of a more full software. So as you can see with the software open, we have all of these boxes on the right. A couple more boxes are available compared to the original configuration. And there's one more tab down here. It's called Cal Constants. So this allows you to calibrate your either a single module or all the modules in your bank to a certain temperature. So you would set all the batteries in a room with a reference temperature. You would make sure all the batteries reached that reference temperature, and then you would go ahead and type in here what the reference temperature was in whole degrees Celsius only. And what you do is you go from ID range, whatever your batteries are. So if you have 20 batteries and the ID range is from 1 to 20, you would go from 1 to 20. And this is after you would start reading on whatever COM port it is, and you would be able to calibrate all of them. So let's first start getting some data from the batteries. So if you don't know the COM port that the adapter is plugged into, you just have to go through the different COM ports and click start read until you find one. So if you can't find your COM port in this box, and you've tested each one in the selection and none of them work, but you know that your adapter is plugged in, go ahead, go over to your device manager by right clicking the Windows icon to device manager. I'll bring it over. I'm gonna scroll down to ports, COM ports right here. And as you can see, we have prolific USB to serial COM port, USB serial port. So this is the one that is mine. So you would basically go through them and you would look for a COM port in here that is not available in this box. And you can usually mitigate the problem of it not being in here just simply by closing the program and reopening it with the adapter plugged in first and opening it with administrator privileges. If that doesn't work, I would suggest restarting your PC, keeping the adapter plugged in, and after resetting, open the software once again with administrator privileges, and you should be able to see the COM port. But if you don't, look into your device manager and you should be able to find it. It will be like a USB serial or USB to serial like this, something like that, a USB to serial adapter. So I actually have two, so that is one of them, but this is the one that we need. So I would see USB serial port, okay, I would say COM5, and if it wasn't here, I would just simply type in COM5 and start reading. Even if it's not in the selection, it'll still work. Must it not work? Well, it's not going to work because I have the wrong module ID. So that's the next thing. If you maybe got a battery secondhand and you don't know what the module ID is, because maybe it came out of a big bank, you will go ahead and once you have the correct COM port, just go ahead and click Locate Battery. So battery is a U1-12 XP revision 2 with an ID of number 4. So I just have to go to module ID 4 and start read. Boom. So here's all our data. So back to the temperature calibration, that is now available for you to go from ID range 1 to 20 if you had your 20 batteries and calibrate it to the reference temperature. And it'll tell you the module is being calibrated and you can pause it, etc., etc. So you have some values here that personally I don't have a clue what they mean. If any of you guys have any idea what these values mean, please let me know in the comments below. I would really like to know. I might be able to find them with some googling or a couple calls to, well, Lithium Werks, but the Valence batteries were now acquired by Lithion Batteries, whatever. So honestly, you probably won't be able to get this information because it's just staff changes and stuff, so they probably don't have a clue. So anyways, if anybody knows what those values are, please let me know. So onto these other tabs that we have down here, we have bat system info. So if you go to stop read, once again, if you know your COM port now, you can go down and hit scan. So if you have a bank of batteries, this is gonna show you all the batteries in your bank with the module ID. So you can find the battery that you want in your bank, find the ID, type it in, and read individual batteries. You can also exit calibration. Boom. Make sure none of them are in calibration mode, and this is gonna exit all of them out of calibration mode. None of them are in calibration mode anyways, but so if you had them in this calibration mode right here. Okay, so I'm gonna go back to start read, and we're gonna go back to this tab. So this is the event log. This is gonna give you a bunch of events. It's an event log. So this is going to tell you the max life temperature and the minimum life temperature, so the highest temperature the battery's ever experienced, and the lowest. So you would multiply that by 0.01, giving you 37.23 degrees and minus 5 degrees. And you have all these other values here. You can have a read here. Millivolts, so this would be 3.7 volts and 2.4. Moving over here, max discharge current, 160,000 times 0.01, so that would be 160 amps discharge current, and 24 amps maximum charge current. Charge discharge cycle count, so this is how many times the battery has been fully charged and fully discharged. Well, relatively fully charged and fully discharged. However, whatever this system counts as fully charged and fully discharged, to count it as a cycle count, that is what it is. I'm assuming probably 80% charged to 80% discharged, probably just to give or take. So SOC cal correction, so state of charge cal correction. So Valence has the state of charge meter for the batteries, so it will show you the percentage charge it is. So as the batteries get older, the internal resistances change. So a state of charge meter will become inaccurate as the battery gets older. So this number is to compensate for age, and it either adds or subtracts this number to compensate for the age and give you a proper state of charge measurement. So here are some other values: calibration count, total number of errors, intramod balance count, reset count, oscillator fault count, mem axis fault count. Couldn't exactly tell you what these mean, but mem axis and oscillator and reset count, I'm pretty sure that has to do with the RS 485 itself and has nothing to do with the battery. I think it's just more to do with the technicals. Anyways, that's the event log. You can also look into the battery info. It's going to give you the model, serial number, the firmware revision, the firmware date, and the firmware time. So this one, firmware revision, is actually, it's different. See how it's 1005477801. The ones that I'm used to is Cerizay, with Cerizay, which we will see on another battery. So I'm just curious, so I'm just gonna take a picture of this using LightShot. It's good software, allows you to take screenshots, and I'm just gonna save that just because if I do see one, I want to compare it. Okay, so a couple more values that it has is it gives you the voltage of each cell bank. So there's 12-volt battery, so there's 4 cell banks. So each this is the voltage, so it would be 3.3 volts. And over here you can change your reference voltage, whatever you want to set your reference to, you can. And over here you have your cell spreads. So you can set your limit in that config file that I showed you earlier. So you would set your cell spread limit in the config file before you open the software. So just for testing, I just set it to 1. So if it goes any higher than 1, the box will turn red to kind of give you a visual alert that the cell spread is too high. And as for these other values, you can set limits in the config as well. And over here you have the temperature sensors, once again multiplied by 0.01, so 24 degrees Celsius, and you have 6 sensors plus the PCB sensor, although I think these 2 last sensors are not working anymore. So once again you have some reference numbers that you can put in. Okay, so the second last box is the general battery information. This should have been the first box I explained, but kind of here, there, and everywhere with this. So you have the current draw in amps. This just says 0.01. That's probably just like a float, just like a floating number. It doesn't really, it pretty much means 0. State of charge is at 95.69%. I can't believe it goes to 2 decimal places. Okay, so watt hour discharge. This is an estimate of how many watt hours is left in the battery to discharge. So 44,847 watt hours. So that's awesome. So the second, the last box here is the data logging setup. So what you can do, I'm gonna hit stop read. And I'm gonna go down here to the software. Down here to data logging. And I'm gonna choose a data logging path. Browse. And on the desktop, as you can see, I have this folder called Valence Data Logging. So that is the path that I'm going to save my data logging to. In description, maybe for certain events or certain projects, you can put a description. So I will put YouTube here, so I know that this log is from the time that I did this YouTube video. Okay, so you can do single sampling or continuous sampling. Data logging path set, okay. So, start read. Once you have your path, well, you could actually, yeah, you can't set your path while you're reading. So you got your path set and your description. So, recording interval, at least 1 second interval. So, how many times, how often do you want to record data? Every second? It all depends on how long you want the log to go. So for like a 24-hour log, you probably wouldn't want it to record every second because that would be a huge amount of values to go through, and the changes over a second would be very minuscule. So it's hard to really see the changes over such a wide scale since it's doing it every second. So for 24-hour, maybe if I'm doing a 24-hour period, think about it. If 24-hour period, if you record once an hour, you're gonna have 24 values to look at. So if you do twice an hour, you got 48 values to look at. So I would probably want twice that. So what, probably 15 minute every. Let's go every 5 minutes. Every 5 minutes, I want it to take a reading. So I'm just gonna type in 5 minutes in seconds in Google, and I get 300 seconds. So that is just what I'm gonna put it. And the reason you want this number is important is because if you want to graph this data in Excel or something, it's very hard to graph a lot of data. It will take so long in all of your CPU in Excel because Excel just sucks for that. So I'm choosing to take a measurement every 5 minutes for 24 hours, and then I will actually show you guys how to graph this information. So you will see maybe a chart with a bar showing you the voltage decline compared to the voltage decline as the battery was being used compared to maybe the amp usage. So you can see how those two numbers correlate with each other with usage. So as the amperage goes up, how much faster the voltage decreases. So I will show you guys that stuff in another video, but just to preface that, you have to know how to set up your intervals so it's not too much data to put into a graph and mess up Excel and slow it right down. So I'm gonna do 300 every 300 seconds continuous sampling right here. I'm gonna click continuous sampling, and it's gonna record continuously until I stop it. So currently there's nothing that allows you to automatically stop it. You can maybe make a script or an auto clicker. Leave your mouse right there if you're going to be away from your computer. Leave your mouse right there and set up an auto clicker to hit stop record after 24 hours. It's all up to you, whatever you got to do. So anyways guys, that is pretty much everything in the Valence Diagnostic Software. If I didn't cover anything, please let me know. Oh, one more thing. So the modules. So, the module ID. This module ID is 4. If you go over here, you can change it to any number you want, all the way down to 128. So if I want to change it to 1, I could stop read and change the ID, and then I would just have to read module 1. So that's the only other thing, just the changing of IDs. So what you would do that for is if you have a bank of 20 batteries, if they all have the ID of 1, when you hit start read on the module 1, you are going to get discombobulated data. It's going to be getting signals from all these different batteries. So it's going to be changing, these values are going to be changing from one battery to the other as it's getting signals from each RS485 transceiver from each battery, because they each have the module ID of 1. So you want to go through your group of 20 batteries and change each battery to have its own individual ID, obviously probably in a consecutive order from 1 to 20. So this is the fourth. Oh, 1 second, got a call. Okay folks, so I'm off the phone. So back to what I was saying. So that's pretty much the last thing to talk about in the software. But another thing I want to mention is there's a couple differences between models. So this one being the U1-12XP Revision 2. So I actually have it hooked up to one of the gray batteries that I showed you guys in the last video. If you haven't seen it, I will put a card for it right now, hopefully I do that. Hopefully I know how to. But anyways, yeah, this one is based on the U1-12XP revision 2. It's actually called the U1-12 BMS. That's the proprietary one that they used in tenant scrubbers. That's mainly the ones that I got a hold of. But if you're dealing with the revision 1, the XP series, I'm not sure if the RT series is the same with the first revision, but with the revision 1, what I will show you is look at revision 2 and all the data that I am being shown here. There's a lot of data that the second revision can offer you that the first revision can't. So let me go and plug in one of the first revision batteries, and I will show you the difference in the amount of data that we are offered. Okay folks, so here we are with the revision 1 plugged in. As you can see, a couple different things right away. Serial numbers are different. There's a lot lower serial number. So assuming they started from 0, this would be battery 34,724 that they made. So really this is pretty low number. Firmware date 4/17/2006. Firmware time 2006 4/16. So maybe this is the date that it was put into the battery, not sure. But anyways, it's an old battery. So the amount of data, well, first off, as you can see, when we over limit, they turn red. The cell spread on this is really high. This was a battery that I was kind of testing. I revived it from 0 volts. So I think one of these cell banks is bad. Looking at the different voltages, it's probably cell bank 1. So I'm gonna recharge that and see if I can correct this, or maybe bring up cell bank 1 and see if they remain balanced. But balance status is enabled, balance status balance inactive, so it's not currently balancing because the voltage isn't high enough. But it will tell you right here, balance active. I think it turns yellow when the battery cell banks are balancing. So over to event log. As you can see, there's a lot less data that it offers. Still offers a lot of data compared to try and plug in some SLA to your computer. You can't even do it, let alone get any data from it, let alone having this many working sensors on it. Nuts. Okay, so other than the a lot less data with the revision 1, that's pretty much it. That's pretty much the only differences between the models. Just a bit less data or a bit more data with the newer models. But hopefully after, well, currently right now, Lithion, the company Lithion has acquired the Valence or Lithium Werks. Well, we know it as Valence, the Valence module design styles. So they pretty much now own the patents and stuff to make the U1-12 RTs, the XPs, all of that stuff. So they're going to be the ones that you buy these batteries from. So folks, that's pretty much all with the Valence module diagnostic software. Like I said, I will be coming to you guys with another video on the software talking about the data logging and how to graph that into bar graphs, maybe line graphs or charts, to get a better visual representation of the data rather than just looking at numbers in an Excel sheet. So anyways, stay tuned for that. If you guys enjoyed the video, leave a like and subscribe. I'm still new to this YouTube stuff, so I probably sound really newbie when I'm commentating, but please give me your tips. Tell me what I'm doing wrong. Maybe tell me what I'm doing right. What do I need to improve on? Thanks guys. See you in the next one.